Chapter 14 in APES is going to deal with food, something obviously we can't live without and something many of us have lots of. How is food produced? A famous quote by Aldo Leopold, who of course is famous in Wisconsin. There are two spiritual dangers in not owning a farm. One is the danger of supporting that breakfast comes from the grocery, and the other that heat comes from the furnace. Kind of the idea that, do people really know where their food comes? Do they know what goes into making food, processing food, and really getting it to the grocery? Likely. Food production has really increased dramatically because populations have shot up exponentially. There's really three systems that we use to produce our own food. First one is croplands. So just as you would think when you ride by a farmer's field and there's a lot of crops out there, that's 77% of our food comes from that. Second, 16% comes from rangelands, pastures, and feedlots. Rangelands would be out kind of in the west part of the United States where they free range things like cows. We do a little bit of that, of course, in Wisconsin too, but not nearly as much as out there. You can see the feedlots down there with all the little piggies in it. Oceanic fisheries result in about 7%, so of course getting fish from the food yields have increased. These are the reasons. While technological advances have gotten significantly better, lots of money by our government has been put into agricultural research. We've got better farming techniques. We've got expanded use of inorganic fertilizers, which arguably isn't that great. Better irrigation. You can see a picture of that ginormous sprinkler in the picture of the right. That's actually an irrigation system, and you see, of course, those around this state also. We've used more pesticides, smarter pesticides, and we've increased crop yield. Result. We need to feed 7 billion plus people, and how are we going to do that? That's the big question. We can use genetic engineering. The problem is our planet's net primary productivity is being degraded, and soil really can only last so long. So what's going to happen when all that system crashes? People that live in poverty must be helped. There are a lot of people around the planet, of course, particularly in developing countries, that do not get proper nutrients. We in the United States tend to not get nutrients. Food that sustains the world, these are the top three: wheat, rice, and corn. The problem with those is they are annuals. They must be replanted each year. There takes lots of energy that goes into replanting these items every year. For example, you need to harvest the seed the year before. You need to store the seed at a seed store. You need to then use tractors to put it in the farm field. You need to fertilize it. You need to put pesticides on it. So it's a yearly process that really weighs cheap. Industrialized crop production, think about industrialized in the United States. We do what's called monoculture growing predominantly in the United States. Monoculture is when farms plant predominantly one thing. For example, if you go through this state or like Iowa, you're going to see a lot of corn. That is monoculture, mono meaning one. The goal is to steadily increase crop yield. There are plantation agriculture, which is industrialized primarily in tropical regions. Plantation monoculture are things like bananas and coffee and soybeans, which are planted purposely. Sugarcane is an example. Those are deemed cash crops, so people make lots of money off that type of monoculture. And of course, feedlots. The idea of feedlots is to grow the animals, fatten the animals, increase use of greenhouses to raise crop in order to feed those animals. So, there's pluses and negative to both those, which we're going to talk about. One of the big pluses of feedlots is it gets all the animals in one area, and of course grows them really big. The problem is, how are we getting them to grow really big? It's very controversial. And do we really need to eat that much meat? Traditional agriculture relies on what's called low input polyculture. Traditional, you can kind of see the picture on the right. That is traditional. We really in the United States don't do a lot of that anymore. Low input means low inputs of things like fertilizers and pesticides. Currently, 20% of the world's food supply is by low input polyculture, particularly in developing countries. That's about 42% of the world's people do that. Two types. There's traditional subsistence agriculture. Make sure you know these. That is when you grow enough food to support your family. Traditional intensive agriculture is that feeds family, plus you make a little extra money. Think about the farmers markets we have around here. Those people are feeding themselves, plus they're making a little extra money off of it too, so they can buy other things. Polyculture is much better over monoculture. It is not as hard on our environment. Closer look at industrial. We had a couple green revolutions. In what's happening with these green revolutions is we're kind of pushing our ideas onto developing nations. Kind of good because they need a lot of food, bad for our environment though. Between 1950 and 1970, we had this first green revolution. What happened where we started planting more monocultures. We had very high yield. It was sustained with fertilizers and, of course, pesticides. We increased our crop yield. So, of course, if we have more food, people are going to be more healthy and we're going to have more kids. Also, the number of crops per year increased with what's called multiple cropping. Multiple cropping is when you plant, for example, wheat, and it grows in a month or two and you harvest it. Then you plant more wheat and it takes a month or two and you harvest it and you keep going on that cycle. That is harsh on our environment. Second green revolution was in developing countries. Since 1967, the ones with ample water, that is. What we're starting to use are fast-growing dwarf varieties of rice and wheat. In other words, we're using genetic modified organisms. So what's happening is we can grow crops faster with larger amount of yield. That's a good thing. The problem, or the good thing, is the use of pesticides and water and fertilizers. Really, good and bad, have actually gone down in some regions because we're not using as much, because they grow quicker, like fertilizers. In other regions too, where we need those fertilizers more, we're putting more on. The good thing though is we can get several crops out of this. The United States agriculture produces 17% of the world's grain. That is what affects our environment more than any other industry. If you go through Kansas, Oklahoma, the Dakotas, you're going to see lots of grain products being grown. It has doubled the crop of wheat, corn, soybean. We're using no more land though since 1940, so we're actually getting better yields and we're rotating crops even more. Again, harsh on our environment though. We're getting huge corporate family-owned farms that control 3/4 of the U.S. food, so the idea of small farms, small traditional agriculture is just going by the wayside in the United States. It takes lots of energy, as I talked about before, to grow, to store, to process, to package, to transport, to refrigerate, which is spelled wrong, and cook that food from farm to table idea. Different growing ideas, polyvarietal, poly meaning many, variety, many different varieties are grown on the same plot of land. So think about potatoes that we grow in Wisconsin. You can get little red potatoes and plant those right next to the Yukon Gold potatoes. You get a variety. That's a really good idea. Intercropping is 2 or more different crops are planted on the same crop at the same time. So in this picture right here, like this is one type of plant right here, this is another type of plant right there. That's really smart. You're not just planting one thing. If you plant one thing like corn, for example, what tends to happen is you get a bunch of bugs that like corn, and that's going to wipe out your entire crop. If you do more than one thing, you don't get as many bugs, and it's not going out either, so we don't have to worry about the pesticides as much. Agroforestry, is agriculture, forestry is obviously trees, / allied cropping, that's when we grow trees and crops together. So as you can see in the picture on the right here, you've got trees that act as wind shelters, and it protects and it holds nutrients in, and it's not as bad on our environment either, and you've got crops that grow in between here, so a really good idea. Polyculture, again, poly meaning many. We plant many different crops together. They mature at different times. Way smart. Not only do you get different foods throughout the year, you use less fertilizer. It protects the soil from the wind and water erosion. We use less insecticides, herbicides, and weather doesn't kill all of the crops, which is good. Low input polyculture, which means we don't use a lot of insecticides, herbicides, and things of that nature, can produce higher crop yields than high input monoculture. So it's really something we should do, and a lot of farmers are starting to do in the United States. The problem is soil erosion, degradation. What happens is preserving topsoil is real critical. Topsoil is deemed a renewable resource unless we degrade it faster than it can renew itself. Degradation occurs when future use of land is decreased. Water, wind, and people cause soil erosion. Keep in mind, water is the #1 reason for soil erosion. Soil erosion is the idea of if it rains out, for example, and water takes the nutrients and deposits them someplace else other than the farmer's fields where they want to grow something. Wind can cause this, of course, too. Sediments pollute water, kill fish, clogs irrigation. So what happens is when that water rushes off, we get all kinds of problems. When the water rushes the soil off, that soil can carry things like pollutants, and that can get into the water like fertilizers and insecticides. Soil, of course, is renewable if it's not eroded faster than it replaced. A couple facts about soil. Erosion in the United States is slowed by planting crops without disturbing the soil. So if we just keep crops in the ground, it actually holds the nutrients and it holds the water really well, and we don't get really large amounts of erosion. And we'll talk about without disturbing the soil in a bit. Classical example was the Dust Bowl of 1930s. What happened was in Oklahoma region, a lot of grazing of cattle. Those cattle ate a lot of the plants, and that soil loosened up. It was not held together by roots of plants. We had a very dry, drought kind of condition, and what happened is the winds were massive that year. It literally picked soil up and brought it all the way over to the Carolinas. It's got people sheets that they were hanging out from their beds dirty, they were drying. So what happened as a result, and that took all the nutrients with it. Congress passed the Soil Erosion Act of 1935, and it began Soil Conservation Service, which is very alive and well in the United States right now. Desertification is defined as when production falls by 10% or more from drought, which is spelled wrong too, sorry, and human activities. Restoration can be from planting trees, grasses, hold in the soil. Salinization is a huge problem we're having with farming, and technology is actually making this a little bit better. What happens is we take water out of the ground in order to feed our crops, so we do irrigation like this. What happens is in the water there's naturally dissolved salts. Some can be NaCl, it can be magnesium, it could be calcium, and things like that. And what happens, as you can see on this picture on the right, is those salts end up on the top of the soil, and as you learned in basic biology class, what that does is it creates a hypertonic solution, so it's actually going to kill the plants. So again, salinization is when we're pumping all this water out, and it's increasing the salt production on top here, and it kills our plants. Something very similar with waterlogging. Again, when we're drawing water out and watering our crops, you can kind of see an example of waterlogging on the right. That's probably more so from rain. What happens is that saline water covers the irrigation, and what happens is it raises our water table. So what happens is we pump water out, and we put that water on here, and we get water, and it raises the water table. The water table, as it comes up, basically gets the roots of the plants wet. If they're too wet, it actually rots them, so that yield is really affected. So how can we conserve soil? We talked about a few of these before. We would need to reduce soil erosion and we need to increase soil fertility kind of at the same time. There's two ways of looking at this. There's conventional tillage. You can see conventional tillage at the picture on the right where the farmer is going through and disking the crops or the field. What happens then in the winter, like around here, is this dirt right in this region is very prone to wind or water erosion, where it's going to pick up and take it, and that farmer is not going to have many nutrients in there. Conservation tillage disturbs the soil as little as possible when planting. So what conservation tillage is, which we'll see in a second, is farmers would leave their fields like this. Those things, those excessive plants from like corn in this case, hold the soil together, and what happens is they'll just go through and inject seeds into here, for example, instead of disking it all up like that and better in our environment. So let's go through some of this. Minimum tillage is, as it says, we don't till a lot. You can see this on the right here. What they're doing is they're tilling it a little bit, but they're probably injecting seeds into that, so it leaves all that vegetation to hold the soil together. And also, even just not disturbing it over the winter helps quite a bit too. No-till farming is we use specialized machines. Like I said, this is the extreme form. This is perfect right here. What he's doing, leaving all this vegetation undisturbed, because quite honestly it's going to decompose naturally, return nutrients too, plus it holds everything together, and he's injecting seeds. Terracing is another way of farming. Land's made into a series of broad terraces that run across the contour of the land. So this is very prominent in like Europe with their wineries, for example, in Italy or other things. That's a really smart way to farm. It reduces soil erosion and really makes use of a lot of land that we wouldn't use otherwise. Contour farming is just simply when we plant crops in rows across the slope of the land. So those two are kind of hand in hand, if you will. Strip cropping is, as the picture shows, we plant alternating strips of row crop with another crop that completely covers the soil. So this one right here, we have something planted here, and then we have something planted totally different right there. That's strip cropping, different strips of plants. That's really good. That's actually a type of polyculture where we're planting two probably different things. Really good for our environment, doesn't suck up all the nutrients in the soil necessarily, and actually some of these plants might actually be nitrogen, make nitrogen, and the other ones may use that nitrogen, so it works hand in hand. A lot of times we do things called cover crops. Cover crops are like soybean, like in this picture right here. I know in Wisconsin what they do is after the potatoes grow, they put in this cover crop, and it grows really quick, like alfalfa. And what happens is it's a nitrogen fixator. So what happens then is they leave it over winter. It fixes the nitrogen, so it gets nitrogen in the soil for the next year. And then what happens with this is it also prevents soil. Agro-cropping, talked about before. Agro-forestry, just another picture of there. It also offers windbreaks and shelter belts. So what happens is we don't get that soil erosion. Organic farming, huge, excellent stuff. We use organic, definition is we use animal manure as fertilizer. We don't use traditional inorganic pesticides or fertilizers for that matter, and it adds soil, bacteria, and fungi. Green manure is the stuff right here. Green manure, like we plow freshly cut vegetation in the soil, and that naturally will put nutrients back in the soil. The knock on organic farming is that it's slow and it's very labor intensive. The good thing is it's so much better for you. You're not getting all those in your system. The idea of buy locally grown food, you can see the picture of a farmer's market up there. It supports local economies. Generally it's organic. If you've ever been to Madison, actually that's Madison's farmer's market right there. Generally organic. Crop rotation is very important too. Plant different crops. The problem is if you plant corn, for example, year after year after year after year, it's going to take those same nutrients out and it's just going to devastate your soil. Inorganic fertilizers can be really bad too. Inorganic, these are the three right here, please realize, and that is nitrogen, phosphorus, and potassium. That's the stuff we traditionally put on our lawns too, but we can't at phosphorus in Wisconsin anymore. That's what farmers put down a lot. Look at the picture right there. You can see that it looks fake. It is. It's stuff, when we talked about the phosphorus cycle, like we take that out of the rock and make fertilizers out of it. It's quick, but the problem is it can get into our groundwater. There's cases of blue baby syndrome, which in like central Wisconsin where there's sand and the nutrients go right through, they have a higher incidence of babies that are born, stillborn. Because of that, inorganic fertilizers, again, can be very good because we can grow lots of food quickly. The problem is it can, if there's too much, it can cause eutrophication. It can also get into our groundwater. That's it for the first part.